Next, we'll look at the problem CSP. So yeah, Pac-Man wants to try out some food in Berkeley, and restaurants are A, B, C. There are 2 drinks, D and E, and he wants to assign to 4 time slots. So yeah, and following are, so the variables are A, B, C, D, E, and their values are 1, 2, 3, 4. And then Pac-Man has the following constraints. For doing this kind of problems, I recommend when doing it, when we see the constraint, we should express it using the undirected graph. And for undirected graph, we will not model the unary constraint. Instead, we'll model the binary constraints. So yeah, let's read the question and do it. So A, C, D, E. So 2 restaurants cannot be taken at the same time slot. So they will influence each other. Any 2 drinks cannot be taken at the same time slot. So they will influence each other. Restaurant A doesn't open for time slot 1, and it's a unary constraint, so we don't do anything on the graph, but we should make sure to look at it later. And the time slot that C assigned to should be greater than A and B's time slot. So yeah, so A, C should influence A and B, and we already draw that. And the drink D and restaurant A should be assigned to the same time slot. So we should draw a line that connects D and A. So that's our undirected graph. What constraints are unary? We already solved it. It's number 3. And for the second one, it wants us to enforce the arc consistency. And A is already assigned to be 2. So for the steps that we do the arc consistency is we change the undirected edge to the directed edge. What we just change the direction of B and C to be this way. And what we do here is, so A connect with B, A, B, C connect with each other. So we draw the directed edge. And so, and D and E. Yeah. Oh, so E shouldn't connect with A. Sorry. Okay. And what values remain in the domain of each variable? So we'll slow down and do it yeah, from start. So like in the real CSP arc consistency, we will put all the directed graph in a list. So what we will do is we'll write A, B, A, C, B, C, B, A, and BA, CB, CA, AD, DA, DE, ED. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. And then we just cross out, like we will get rid of the directed edge. And if there are for arc consistency, we say is for the variable for every value for variable in the tail. Like suppose we'll make sure the first one is the tail. So for every value in the tail, there should be some value in the head of the directed edge that will make this assignment successful. And if there's no value in head that makes this assignment successful, then we will just get rid of that value in the tails variables domain. So we'll look at it. For the first one, AB. If A is, for first one, we'll look at AB. And so if A is, like we already know A is 2, and we see that any two restaurants cannot be taken at the same time slot. So B cannot take 2. So we'll mark 2 off from B's domain. And are there other constraints for A and B? I don't think so. So, okay, we'll cross out this and add every couple of nodes that whose head is B. But since all of the pairs whose head is D are already in the queue, we don't do anything for it. So next we'll look at AC. So are there any constraints for A and C? C must be greater than A and B. So for A to C, A is 2. So if C is greater than A, so C should not be 1 and 2. So we take out the value 1 and 2 from C's domain and add every node that point to A. And since they're all here, we'll also just disregard of it. For the third one, BC, from B to C, we can, do we have any constraint values? So what B can take is if B is 1, so B's domain now has 1, 3, and 4. So if B is 1, then C can be 3 or 4, so it's correct. If B is 3, then C can be 4, and 3 is also correct. We're not prone it. And if B is 4, then C cannot be any value that is strictly larger than B. So we should take 4 out of B's domain and add all the pairs of directed graph that points to B, or just whose head is B. So we can see the first one, AB, its head points to B. So we'll add it to the back of the list. AB added here. And cross out this one. Next, we'll look at BA. So from B to A, when B is 1, then they cannot take the same time slot. So when B is 1, then A just can be 2. Yeah, correct. And when B cannot be 2, B can be 3. When B is 3, then A is A. So A is 2, then so it doesn't affect anything from their domain. We just prone this edge and go on. For CB, following that, for CB, let's check the values in C's domain. If C is 3 and A is 2, yeah, correct. And if C is 4, A is 2, correct. So yeah, it's really good. So we can also, okay, sorry, we can also cross out CA. Oh, we should do a CB first. So CB is also the same. We can also cross it out. So yeah, it doesn't affect anything. So what we should remember is if nothing is taken out from the tails domain, then we just prune that edge instead of doing any and without doing other things. For AD and AD, we can see that their constraint is A and D should be assigned to the same time slot. So these time slots should also be 2. We prune 1, 3, we get out 1, 3, and 4 from this domain. And we see if there are other like directed edge pairs whose head is D, but we see that they are all already in the list, so we don't do anything. Next one, from D to A. From D to A, and since 2 is already taken, like only thing left is 2, then it'll be correct. And we clean up this and do it. So DA, yeah, correct. For D to E, D can take 2. If D is 2, E definitely can take 1, 3, or 4. So it's also okay. For E to D, E can be 1, 3, 4, but we can see any 2 drinks cannot be taken at the same time slot. So if E is 2, then D's only value is 2. They will conflict, so it's not good. So we will take 2 from E's domain and add any directed edge pairs whose head is D. And we see that it will be AD and ED, since we take ED out already. Oh, no, since ED is already in the queue, we don't do anything for it. Instead, and also we should add AD back in the list. So for ED, we already do it. And for AB, because we just add this, so A can be 2 and B still can be 1 and 3. So it's acceptable. And the last one will be AD. So A can be 2 and D is also D's only value is 2. So it's also acceptable. So now we cross out all the pairs in the list, and it just says our AC3 is done. So let's see what we are left. We're left with B equal to 1, 3, and C is 3, 4, D is 2, and E is 1, 3, 4. And this will be our solution for that. For B, now Pacman wants to solve this problem using a different approach, local search. So it says, which variables are conflicted in this assignment? So A can be 4 if and B is 1. So it doesn't conflict. And for C to be 3, then we can see C will be conflict with B. So C, because C should be, okay, so C will be conflict with A. So this two, we should choose both of them because they're conflict. And for D, D should be in the same, assigned to the same time slot with A. So, but now it's 2, so, and A is 4, so we also choose it. For E, basically it cannot choose the same time slot as D, but it's 2 and D is 2, so we choose E. This will be the conflicted variables. For the last one, assumes that we decide to change the value for A, and we want to have the minimum conflict heuristic. Which new value should we assign to A? So if we assign to, so now we want to make sure A doesn't open for time slot 1, and it should be smaller than 3. So maybe we'll try 2 to see if it has less conflict. So first we resolve the conflict between A and C, and A and D should also be assigned to the same time slot. So we also resolve the conflict between A and D. And we didn't add any new conflict. So it seems we have the minimum conflict heuristics. And so if we assign A to be 3 or 4, A will still conflict with C. So we will choose 2 as our final answer. So this is the CSP problem.